Do we have a prediction for when the universe will stop its expansion? Did we find hypervelocity stars in M31? What does it mean when planets go retrograde? And in Q&A Plus, could the Big Bang come from a white hole? All this and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Peter Keyson, can we calculate when the universe will stop expanding, even with optimistic assumptions? This is a thing that astronomers have been trying to do for a long time. And, back in the mid 1990s, there was this question about what is the ultimate fate of the universe. One possibility is that the universe has so much gravity pulling all of the various things together and not enough momentum and velocity that over time the universe would expand and then eventually it would stop, and then the mutual gravity would pull everything back together and you would get what's called the big crunch. Essentially, the evolution of the universe would go in reverse. The other possibility is that there's enough momentum in the expansion of the universe that the universe will coast to a stop over infinite time. So if you right at the very end, when you reach infinity and you check the time, everything will have just coasted to a stop. And then the third possibility was that it's so much that even in infinite time, the universe will still be coasting apart. And so then they looked at what they considered to be a really useful standard siren known as a type 1a supernova and tried to measure, and this is done this was announced in 1998, they were measuring the expansion rate of the universe, and what they found was it didn't fit any of those three, that in fact the expansion of the universe is accelerating, and that not only is it not going to collapse in on itself, not only is it going to not stop perfectly or just keep drifting but slowing down. In fact, it's going to accelerate and just get faster and faster and faster. Things are going to fall over the cosmic horizon and everyone will feel all alone and scared. And this is dark energy. And this is what won them the Nobel Prize for this discovery. And even today, we still are trying to figure out what is the nature of dark energy and what influence is that going to have. So can we calculate when the universe will stop expanding? Never is when the universe will stop expanding. It will not only never stop expanding, it will keep expanding at an accelerating rate infinitely into the future. John de Keizer, have hypervelocity stars been detected in M31? So hypervelocity stars are the stars on escape trajectories. As long as your star is going above a few hundred kilometers per second, it is going fast enough to be able to escape the gravity of the Milky Way, and it's going to head off into the cosmos. And we have identified, thanks to Gaia, many of these hypervelocity stars here in the Milky Way. And the cause is still uncertain. That the cause might be that you've got two stars that are in a binary system and one of them goes supernova, and then the other one is just hurled away because of the conservation of angular momentum, and now it's like a slingshot. The other possibility is that as you get really close to the supermassive black hole at the heart of the Milky Way, then you can undergo this three-body interaction with other stars that are there, and you can get kicked out on this trajectory. And maybe there's other ways that you can have hypervelocity stars happen, but they definitely exist. And so because so many of them have been found in the Milky Way, it's assumed that there are ones that are being thrown out of Andromeda as well. From what I can tell, they haven't been observed yet, although, we are getting better and better images of Andromeda. Just in the last couple of months, we got a new image of Andromeda from the Hubble Space Telescope that is 10 years in the making, hundreds of images from the Hubble Space Telescope. It is the highest resolution image of Andromeda ever taken and has tens of millions, maybe even billions of stars that are in this picture of Andromeda. And so if there are hypervelocity stars leaving the Milky Way, they've got to be leaving Andromeda. And so it's just going to be a very difficult job to do a Gaia, but for Andromeda, that you could actually detect the motions of stars, the speed and the velocity. the way we detect the motion of a star here in the Milky Way is we use the parallax method. The Gaia spacecraft is the one that does this, right? And Gaia observes the star when it's on one side of the sun, and then 6 months later, it's on the other side of the sun, observes the star again, uses the parallax method to chart the motion of the star. But the parallax method only gets you a few tens of thousands of light years away from the Earth, the sun, before you just can't measure the accuracy of the motions anymore. So for you to be able to detect a hypervelocity star in Andromeda, you need to be able to do the parallax method on Andromeda to find the stars that are moving. And then you have to do like redshift measurements on those specific, I guess, blue shift, if they're moving towards us, to be able to detect those hypervelocity stars and really calculate the speed that they're moving towards us. So like, I don't think it's been done, but there was a paper that we covered in Universe Today that it's almost certainly happened. And then in fact, because there are hypervelocity stars leaving the Milky Way, hypervelocity stars leaving Andromeda, they have probably swapped stars. And so the idea that's really cool is that there are probably stars from Andromeda already in the Milky Way, because, our two galaxies, although they're destined to merge in the next 7 billion years, they're already starting to overlap with their dark matter halos. Kindness. What does it mean when planets are in retrograde? So normally the planets go eastward in the sky from night to night to night. If you go out at the same time every night and you look at the position of the planet, night after night, the planets will go eastward. But because we are in orbit around the sun, our perspective of the planet will change, and sometimes the planet will appear to go westward, and that's known as retrograde. And so often planets will take this sort of, they'll be going eastward, and then they'll stop, and then they'll go retrograde, and then they'll go eastward again, and then just keep doing that. And for the longest time, this was actually like one big puzzle about the structure of the solar system. And to explain this, Ptolemy, like back, was one of the ancient Greeks before BCE, had come up with this idea that, the Earth is at the center of the universe, and all the planets in the sun are orbiting around the Earth. And the way you explain the motions of the planets is that they're on these sort of have these cycles. They're on smaller things that are turning around, and that can explain their orbital eccentricities and explain when they go into retrograde. And then Copernicus came along and said, well, what if we just put the sun at the center? That explains the retrograde motion. And Tycho Brahe said, well, what if everything follows an elliptical orbit? Then that explains the sort of the movements of the planets. And so with what Copernicus came up with and what Tycho Brahe came up with, it explained this retrograde motion. Now, I don't understand why people who follow astrology place some kind of emphasis on retrograde motion, like has some kind of influence on our bodies or something. I don't know. It's time to shout out our new patrons at the $5 level and above: ArcFen, Mingo in Vegas, Tom, DJ, Michael Taylor, Lee, Sven Heitland, Gareth, Paldawar, Brett Gledhill, and Omnicronos. Join our community at patreon.com/universetoday. JE, the number of visible satellites has exploded, and my understanding is that this is going to grow. Are we working on strategies to mitigate this for observers? No. That's the short answer. If you'd like the long answer, no. If you want the even longer answer, so the problem is that the satellites are launched in constellations that work well for the satellite operator. And so they're going to go in random trains and random rings around the Earth that overlap. And we see all kinds of potential collisions between different satellite operators all the time. And even though the satellites themselves aren't necessarily bright enough to see, like you could see some satellites, but if you could actually see all of the satellites that are flying overhead at any time, the sky would look like this grid of moving stars in all directions, because there's so many of them. You're going to have dozens of satellites overhead now, and eventually you're going to have hundreds overhead at all times. And we can't see them with our eyes. They're too dim for us to be able to see. They're only visible when they pass in sunlight, and they're not visible once they pass into the shadow of the Earth. So these are all things in their favor. But for telescopes, they are gradually just increasing the light pollution that we see. And not just that a satellite passes directly through your field of view, but just all of the satellites are starting to contribute to light pollution. They are all reflecting some amount of sunlight. And it's thought that that is sort of already made light pollution by about 10% worse. And we haven't, we're at 5,000 satellites today. The goal is 30,000 just Starlinks plus Kuiper constellation plus OneWeb plus whatever the Chinese decide to do plus whatever the Russians decide to do. Like, we will hit 100,000 satellites in a couple of decades. I feel pretty confident to say that. And so no energy really is being spent on mitigation. Starlink made a couple of things. They tried painting their satellites a little bit darker. They tried putting a shade, a visor on the satellite so that it blocked some of the reflective areas on the satellite. And those helped a bit, brought the magnitude of the satellites down a bit, and sort of a work in the right direction. Ideally, these negotiations for preserving the night sky versus letting people do what they want to do would have happened before the satellites were launched. And you would have had things like, well, here's no satellites can fly directly over or within the field of view of various observatory locations, but people in Chile want their internet, people in Hawaii want their internet, and so that would no one's going to fall for go with that. But then the other thing is you could say, well, we're going to provide really accurate ephemeris, we're going to provide really accurate location data to the astronomers so they know that when they need to be able to not take a picture because they know that a satellite is going to drift through their field of view. And there's some progress in that, but it's not very accurate. It's the kind of thing that the satellite operators have to maintain. And there are security issues as well. So, we know that the Department of Defense needed Vera Rubin to not image the spy satellites that are flying overhead because it's so good. It would provide information, and then the data is publicly available. So anyone would be able to look through the data and be able to see the locations of the US spy satellites. And so now that information has been scrubbed from Vera Rubin. And partly, I think there's going to be timing. So Vera Rubin doesn't take a picture when it knows there's going to be a satellite in the field of view. And so it doesn't get the streaking. So you can imagine scenarios where astronomers and satellite operators could live in some degree of harmony to a certain extent, but that is a horse that is already fleeing from the barn. And all you have to do is look at the existing level of light pollution that is already around the planet Earth. 1/3 of humanity can no longer see the Milky Way. I'm sure many of the people that are watching this right now cannot go outside and see the Milky Way. Now, I can't because it's raining and cloudy and snowy, but that's a different problem. When skies are clear, I can see the Milky Way. And I would be so mad if the cities nearby took that away from me. And so I think that if you're mad about the potential light pollution from satellites, you should be furious, just outraged that your city, your town, your country is pointing their lights up into the sky and ruining our view of the night sky. When you have truly dark skies, you can see the Milky Way, you can see the stars, you can see the planets, you can see fainter objects, galaxies even. You feel this connection with the universe. And you just don't get that when you go outside and all you can see is a couple of the brightest stars. And this has already been taken away from you. And you didn't even put up a fight. But you can. There's the Dark Sky Association, which is trying to fight light pollution, teach cities to just point their lights at the ground as opposed to up in the sky, as well as designate dark sky places that we can go and connect with, where we know within a couple of hours drive, we can go to a place where we can see the Milky Way, where we can see dark sky objects, where our telescopes work better. So this is a large problem. And what has already happened on Earth is now going to happen to space. But the people watching this right now are going to have a hard time doing anything about the space version of it. But you can do something about the ground version of this. You can audit the lights in your house so that they don't contribute to light pollution. You can go and talk to your city and make a stink and talk to your neighbors and get them to fix this problem. And there are cities in the US, Tucson and a couple of other cities which are close to the observatories, and they do this. Like it's kind of amazing that you're walking outside and yet you can still see a ton of stars in the sky because they have these city ordinances that are pointing the lights in the correct direction. And it's not that hard. And so I think that's like, if you feel at all frustrated by this, please take action because you can. And although you're mad about the satellites, which fine, like do, target that rage at getting lights sorted out down here on Earth. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. This week's bonus question, could the Big Bang be a white hole? I'll put a link in the show notes. All right, those are all the questions that we had this time. Thank you, everybody who asked your questions in the YouTube comments, everybody who joined us for the live show. We are now halfway through our summer hiatus. Have you missed us? Now we'll be back in a month, but we've still got lots more content coming out all through the end of the summer. I'm going to give you an update on how things are going with Universe Today. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Braley Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Balock, Cy Nelson, David Gilton, David Matz, Evan Pro, Greg Feely, Hudson Ward, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Smits, Michael Purcell, Modzo, Paul Robach, Renkaidu, Robeck, Sean Sargent, Stephen Fowler Munley, Vlad Chaplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So it's been about 5 months since we made the cut of all of the ads off the Universe Today website and went to 100% patron funded. It's actually not 100% patron funded. We make a little bit of ads from YouTube because they won't let us turn them off, but we are mostly funded by Patreon. And I've been doing this now for 5 months and it's been amazing. I'm now able to sort of just like delete every email that comes in for sponsorship messages, private equity requests, everything. I just delete it all and just focus on finding the best space news stories that I can. We're now producing a lot more content, which is a bit of a problem because I'm on a fixed income. And so I'm kind of limited by how much I'm able to afford for the writers. And so I have to sort of figure out a way to really properly balance this out. But unless I really mess this up, we're in a sort of a perfect place where I'm able to focus on finding the coolest, best stories for the writers. They are able to write those stories. I'm able to do further interviews with some of the people behind those stories. We're able to gather that together and put them into the Space Bites show. And everything is firing on all cylinders and it's great. And now it's sort of like, oh man, I wish I could pay for more content. I wish I could bring on more writers. I wish I could expand our journalism. We're essentially where we were back in the days when we had ads, but except we don't have to deal with the declining revenue, which is kind of amazing. So if more people want to get involved, we've got a special deal on our Patreon over the summer. So through till the end-ish of August, we're offering 57% off your first month of Patreon with us at any level. And of course, you get to support this independent space journalism, which is more important than ever when you see how much journalism is on the decline, how business models are failing, how AI slop is filling the internet. I think these independent voices, a dedicated team that is focusing on being the best space journalists we can, is an important thing to have in this world. But you also get access to our entire backlog of all of the patron-only content. And for example, I'm just now recording my patrons-only question show podcast with my producer, Anton, and it's probably going to be 4.5, 5 hours long. And we produce one of these every month. They're great. And of course, you get all of the previous ones that we've done, all of the overtime episodes that we've done in the past. At some levels, I will shout out your name, and everybody who signs up gets to do a personal, private conversation with me. It's kind of like watching this YouTube video, except I answer back. So if you're interested in that, just go to patreon.com/universe today and you'll see the offer up there at the top of the screen until August 25th. And so for everybody who is already supporting us, thank you so much. This has just been the best. And for those of you who are interested in joining this amazing community, come to patreon.com/universe today. All right, we'll see you next time.